In this lesson, we shall look at analytical geometry, but also we shall go and focus on Euclidean geometry as well. In the diagram below, P with coordinates 1 and 1, and here is the point P, clearly there. Q with the coordinates 0 and -2 here, and R are the vertices of a triangle. The angle PRQ is theta. You have the angle PRQ, which equals theta here. Right, the x-intercepts of PQ and PR are M and N respectively. So you have M and N respectively. The equations of the sides, PR and QR. Right, so you have PR and obviously QR. The examiner has shown those. And we have the equation y equals minus x plus 2. The other equation has been written in the form x plus 3y plus 6 equals 0, respectively. Now, T is a point on the x-axis as shown, and we can see clearly the point T over there. Okay, good news. We're excited because we have a very, very interesting question for us to solve at the moment, and let's get started. Now, the first question is, we need to calculate or determine the gradient of QP. So we identify Q, right, and P. And now if the obviously examiner uses the language QP, so you're moving from Q to P, in which case you have X1, Y1 here, and X2, Y2. This is like vectors. Okay, right. So we want the gradient of, so in other words, we're looking at 3.1 and to find the gradient. I'm going to send you homework after this. Right, the gradient of QP equals therefore delta Y, delta X. Right, so if you have delta Y, delta X, we continue to therefore analyze these which match quotient. Right, with absolute quotient, and we solve this question. Okay. Right, we are most certainly ongoing here, and we have this. So to therefore continue analyzing this, so it is delta Y, delta X. Right, so which is exactly the same as Y2 minus Y1 over X2 minus X1. Right, in which case we therefore continue to say, Y2, what is Y2? Y2 is 1 and Y1 is -2. Divided by X2 is 1. What is X1? 0. 1 plus 2, so this is like a plus. So negative by negative, it's a positive, so that 1 plus 2 gives us a 3 over 1, and the result is 3, and therefore we have the gradient. The gradient of QP equals exactly 3, like so. And we have therefore found the gradient there. Okay, the gradient equals exactly 3. Now, we want to prove that the angle PQR equals 90 degrees, right? The angle PQR is 90 degrees. So we want to show that this angle here in 3.2 PQR, this angle here equals 90 degrees. How do we show that that angle equals 90 degrees? Right, so there are a couple of ways to do this, but we already know something. What do we know? We already know that the gradient of the line segment PQ equals what? Equals 3. Okay, because PQ, or rather QP, so you have the line segment QP, right? It's just a line segment with endpoints clearly defined. And we want to prove that the angle PQR equals 90 degrees. So the angle PQR equals 90 degrees. How do we show that? Right, first things first, we already know. So in other words, we must know two things. We'll need to know the gradient of PQ. Or you can say, use the same language here as the examiner. So we need to know the gradient of QP, right? Gradient of QP, so we write that one. And this gradient of QP is 3. And therefore, obviously, look at the fact that we have the equation of the line in contact with QP. And the line has the equation this. What is the equation? The equation is x plus 3y plus 6 equals 0. We need to write this equation in the required form, but we need to write it in the form y equals mx plus c. Okay, now making y the subject, we have 3y is minus x plus 6. Y equals minus 1 over 3x. You divide 6 by 3, obtaining a 2, like this. Simultaneously, this actually gives us more information, but it asserts to us that we have the gradient of the line here with the equation given. The gradient of the line QR. And the gradient of the line QR is what? Is minus 1/3. Okay, thus, or hence, the gradient of QP times the gradient of QR equals the gradient of QP is 3 multiplied by the gradient of QR is what? Is minus 1/3, like so. Multiplying 3 with minus 1/3 gives us a minus 1. Okay, what is the meaning of this? We've found and we've established the fact that the gradient of QP times the gradient of QR is minus 1. And this means, therefore, that at this point, we can then say the gradient of QP times the gradient of QR equals minus 1. Okay, right. We know the equation of a line is y equals mx plus c. And we know that if the equation of a line is written in this form, it can be written in the required form y equals mx plus c. And this is called the slope-intercept form of the equation of a line. Right, it is called the slope-intercept. Right, slope-intercept form of the equation of a line. Okay, now, if then the gradient here, the product of the gradients is minus 1, so you have, therefore, the implication. And what is the implication? If you multiply two gradients and you obtain minus 1, it means, therefore, at this point, QP is indeed perpendicular to QR. Why? Because the product of the gradients is minus 1. It therefore means that the two lines are perpendicular. In this case, QP is perpendicular to QR. Okay, once again, I'm going to send you homework at the end of this. Please try the homework. I'm going to make it a bit more mandatory for you to make some submissions to me of the homework so that I can mark the homeworks so that you can see your progress. Because if I just give the homeworks, some of you might just be sleeping on the homeworks. And you see, if you sleep on the homeworks, it's not really going to be useful very much. Okay, but we are excited to continue to the next question. Okay, just to sum up our answer here and to summarize, we have established the fact that now QP is perpendicular to QR. Why? Because the product of the gradients is minus 1. You know, so yeah. Next question. Right, in the next point, what to determine the coordinates of R? The coordinates of R. What determine the coordinates of R? Right, to determine the coordinates of R, what do we do? Straightforward. We can see there are two lines. The line whose equation is y equals minus x plus 2. Another equation whose line is x plus 3y plus 6 equals 0. These two lines intersect at the point R. And we want to determine the coordinates of R. And this is like two lines intersect at a point. We know the equations and we can solve them simultaneously. We proceed as follows. We have y equals minus x plus 2 here. Next equation, this one here, is the equation x plus 3y plus 6 equals 0. Okay, these are the two equations. We've just written them down. We're going to go back to grade 10 and use what we call the substitution method. We can also use elimination. So we proceed to say substitute. Right, so we say substitute. Substitute equation. Equation 1 into 2. If we substitute equation 1 into equation 2, we have x plus 3. What is y? It's minus x plus 2. So we're actually substituting equation 1 into 2. Plus 6 equals 0. Minus 3x. 6 plus 6 equals 0. What is x minus 2x? Minus 3x. It's already minus 2x. Now, 6 plus 6 gives us 12. If you move it across, it becomes exactly a negative 12. And so, what we then have is minus 2x equals minus 12. Divide by minus 2, so that x equals 6. X equals 6. And so that becomes the actual value of x at the point R. And simultaneously our y equals, what is our y? Okay, use one of the equations, minus x together with 2, add it together. What is x? Right, so you have that x is minus 6 plus 2. What is minus 6 plus 2? It's a minus 4, like so. Okay, let's just remove this equal sign here. Equation 1 is y equals minus x plus 2, and we have rewritten the equation. We substituted in the place of x, we have minus 6 plus 2 minus 4. What are the coordinates of R? What are they? Wow. The coordinates of R, therefore, are as follows. Are actually exactly 6 together with a minus 4, like so. Now, the couple of things that remain very, very important for us to take into account. But what do we do? Next, we solve the next question. Okay, to summarize, we have been able to proceed to determine the coordinates of R. How did we do that? We realized that there's a line here whose equation we know. Another line exists whose equation we know. They meet at a point, and when they do, we have a point of intersection. A point of intersection is the point R. And the coordinates have been found, exactly 6 and minus 4. Next question. Right, in the next case, we continue to look at the same diagram, but want to calculate the length of PR. Okay, we already know the coordinates of R. The coordinates of R are exactly 6 together with negative 4. They form coordinates like this. PR. P is there. Okay, P is up there. And we know that P has the coordinates 1 and 1. So you're going to write it down. We know that P has the coordinates 1 and 1. And we want to find the length of PR from P to R. What is the length? Right, so that in the end, we have x1, y1, x2, y2. So what is the length of PR? So we can see, therefore, that the length of PR is as follows. What is the formula for the length? The length is also called the distance formula. So the length of a line segment is obtained by using the distance formula. x2 minus x1 squared, y2 minus y1 in parentheses square, like so. We proceed. Okay, this one is called the distance. It is called the distance formula. we use this one to find the distance between 2 points. We perform the valuation of the distance, PR, equals the giant, the big square root, x2, 6, x1, 1, y2, -4, y1, it's a 1. Oh, okay, so it's a -1. So you put a minus y1, so it's -1 here. Right, so yeah, let's continue. Which means PR equals, what is 6 minus 1? It's a 5 squared. -4 minus 1. It's a -5 squared. 25 plus 25. What is 25 plus 25? It is exactly the square root of 50. It is exactly the square root of 50. So obviously we have that PR equals the square root of 50. But the square root of 50 is 25 times 2. What is 25 times 2? Square root of 25, square root of 2. 50 is 25 times 2, square root of 25, square root of 2. What is the square root of 25? It's 5 to the square root of 2 units. This gives us that in simplified such form, so this is the length of PR, which is 5 to the square root of 2 units. So here, this one is called a simplified set. So obviously, this is said to be in simplified sad form. Simplified sad form. This is what we have. Where's the question about, because the examiner said, leave your answer in sad form. What is a sad? Well, a sad here is the square root of 2. The square root of 2 is a sad. Right, because why? Well, because the square root of 2 is irrational. If the square root of a number is irrational, therefore it is called a sad. Right, let's look at 3.5. Determine the equation of a circle passing through P, Q, and R in the form that. Let's look at 3.5 together. In 3.5, we want to determine the equation of a circle passing through P, Q, and R in that form. What do we do here? What do we do here? Right, determine the equation of a circle. This circle passes through the point P. Right, the point P is up there with the coordinates 1 and 1. And we want to find the equation of a circle that passes through the points P, Q, and R in that form. Okay. In R, we know very well, find the coordinates 6 together with -4. Okay. So now, if this is the case, there are a couple of things we know, because this we already know. This is what? We already know that's an angle of 90 degrees there. So to find the equation of a line, we just need to, so if the circle exists, as it surely does, and the circle passes through those points, like so, right, just like as shown in the diagram. Now, I want us to analyze this, but with much caution. So at this point, we continue to determine the equation of a circle passing through P, Q, and R in that form. Okay, this circle here clearly has an angle of 90 degrees inside it. That is subtended by this line segment from boundary to boundary. And then now we're able to see that this is it's an angle in semicircle from Euclidean geometry. We know, therefore, that this line segment is what? And a chord. A chord is well, chord means you have this. So there's a chord like this. There's a special type of chord that passes through the center. This is a chord. This one is a chord. Okay, so let me write clearly here to avoid ambiguity. Because somebody will be like, okay, what do you mean by chord? Right, so this one is a chord. This from the boundary to boundary is called a chord. Now, what do we call this chord? Because chord, it means that it's just a line segment from the circumference to circumference of the same circle. Okay, now, what do we call this type of a chord that passes through the center? What do we call it? What do we call that chord? What is the name of that chord? Anyone?
Diameter.
It's called a diameter. Well done. Thank you so much. It's called a diameter. I was just testing you to see if you can relate to that. So, yeah, to determine the equation of a circle passing through the points P, Q, and R, we are able to then say there is a circle that passes through P, Q, and R. And therefore, this one is the diameter because it's obtains an angle of 90 degrees. We know that from Euclidean geometry. It is an angle. This one is an angle in semicircle subtended by diameter. Okay, if it is an angle subtended by diameter, what can we say about this? We can say we can be able to find the center of this circle, because by finding the midpoint of this circle, and we can call the center O of the circle. Okay, there's already point O there. We can give it a different name. Right, we can give it a different name, but it is necessarily the center of this circle. And this center, we can actually be in a position to play around with it. Let's play around with this circle, with this center, because we want to find the equation of this circle. Right, so to find the equation of a circle, we need a center and the length of the radius. So now, because if we want to find the equation of a circle, what is the formula? It's this one. Because the equation of a circle passing through P, Q, and R in this form, so you have x minus a squared plus y minus b squared equals r squared. And therefore, what is the center? What are the coordinates of this? Because now this is the answer must look like this. The equation of the circle must be in this form. But when you just need the center, what is the center? So the center now, we note that PR is the diameter. PR is the diameter. PR is the diameter. Chord subtends 90 degrees. Why is PR a diameter? It is this PR is the diameter because it is a chord that subtends 90 degrees. So we can be able to find the center of circle. Can be able to find center of circle. Which is x1 plus x2 out of 2. y1 plus y2 out of 2. All right, so this one is x1, y1, x2, y2. x1, 1, x2, 6 out of 2. y1 is 1, y2 is minus 4 out of 2. 1 plus 6. 1 plus 6 is actually 7 out of 2, and 1 minus 4 is a minus 3. Minus 3 out of 2 And we need to find the, so we therefore know that the coordinates of the center are 7/2 together with -3/2. So this becomes this is the center of the circle. If this is the center of the circle, we just need to find out the distance between we need to find the radius. Okay, so the distance between the center and the point R, for example, or the distance between the point P and the center. So, or alternatively, you can just find this, which is the easiest one. You can just find PR. Did you find PR? Yes. Wow. Awesome stuff. We found PR. The examiner just wanted to give to us. So we found PR, and PR was found in the previous question. We found PR in simplified set form to be actually 5 to the square root of 2 units. PR was found to be 5 to the square root of 2 units. So we continue to state that one. PR is 5 to the square root of 2 units. And if this is the case, then what is the radius? So we're able to state that the radius. Okay, so obviously, I mean, the PR is a diameter. It is a diameter. Okay, diameter, radius. The radius, therefore, means that you take the diameter and divide by what? And divide by 2. Take half of the diameter. Like so. So we have the following. Okay, yeah, so we have this one. Which is, okay, so the formula is x minus a squared plus, open bracket, y minus b squared. So what is our a? A is 7/2 there. So y'all just use the same color, doesn't matter. So it's x minus 7/2. You square this plus y. We put a minus. So you put a minus here, and this is exactly -3/2. You square this, and it becomes the r squared, the square of the radius, and the square of the radius. The radius is 5 to the square root of 2. So we can write that one down. 5 to the square root of 2. Okay, you square everything, but like everything. Okay. So if this is squared, and then you add here. Okay, so it's like 7/2. Okay, you have 7/2 like this. And then if you square this here, it becomes, if you square 5, it's 25. You square the square root of 2, becomes a 2. And you square 2, it becomes exactly a 4. And if you simplify these, 2 goes how many times into 4? It goes 2 times, and this gives us exactly 25/2. Right. Right. 25/2. Excellent stuff. 25/2. And therefore, this is the equation of the circle that the examiner wants. We can write it down, but more compactly, and say, okay, Mr. Examiner, the answer to the equation you want is this one here. It is exactly x minus 7/2 squared plus, and then you have the other y. Okay, y'all. 7/2, then you have y plus 3/2. And the result is 25 out of 2. The result is 25 out of 2. And this here in green is the equation of the circle in the required form: x minus a all squared plus y minus b all squared equals the radius squared. Okay, so you need to learn how to deal with circles, but also what is the equation of a circle? The equation of a circle is x minus a all squared plus open bracket y minus b all squared plus r, which equals r squared. Okay, this is the equation of a circle. Is this the only equation of a circle? Well, no, it's not. They are different forms of the equation of a circle. What other forms exist? Let us look at the following. You can have as well like x squared plus y squared. X squared plus y squared is r squared. So this becomes the equation of a circle that has center at the origin. It has its center at the origin, and therefore this one here is the equation of a circle with its center at the origin. So that's something that you need to take note of. Okay, so this one, if the a and the b are both 0, 0 and 0, and then we have x squared plus y squared is r squared, this becomes the equation of a circle whose center is at the origin of the plane. Okay, we continue to celebrate more mathematics, but to solve more math by doing the next question as follows. Right, we are able to do 3.6. Determine the equation of a tangent to the circle passing through P, Q, and R at point P in that form. So obviously, I mean, we have that the point P has the coordinates 1 and 1. And want to determine the equation of a tangent to the circle passing through P, Q, and R. Remember that we found the equation of a circle passing through the points P, Q, and R in that form, and we're done with that one. But the examiner is saying, hey, buddy, determine the equation of a tangent this time around to the circle passing through P, Q, and R at P in that form. Okay, there's a tangent at P. Right, P is the point upstairs here, and therefore now there's going to be a tangent at P, which is going to be a tangent to the circle. Zoop, straight line like that, and the circle passes through the point P, and you have this kind of a diagram. Okay, this is a circle, but it's not to scale. I'm just trying to show the point P is just up there. Okay. Now, if the tangent is there, guys, how do we therefore proceed to find the equation of a tangent? Very, very easy. But first, to find the equation of a tangent is a line in the form y equals mx plus c. This equation of a line, I said, is called the slope. Intercept form. It is called the slope intercept form. Okay, I'm going to give you the homework at the end of our discussion, and you're going to practice more and make sure that you're good. But we want to find the equation of a tangent. So now to find the equation of a tangent is something that you need to know. First things first, what have we been able to get here? And what do we know? We know a couple of gradients. These gradients that we know, are they enough? Are they not enough? We check. We need a gradient of a radius. Seven over 2 minus 3 over 2. 7 over 2 minus 3 over 2. Okay, so we want to find the gradient of a radius. Now, a radius, obviously, it's a line segment through the center of a circle, from the center of the circumference, like half the diameter. That's a radius. So now we want to determine the equation of a tangent to the circle passing through those points. What do? We are able to take note of the following. And the question was then saying, what is the gradient of the radius? Whoo! This is awesome. This is the gradient of our radius. The gradient of the radius. So in other words, you know that the gradient of the radius is -1. Okay, yeah, we can see that this is the radius. This is the equation of the radius. So the gradient is -1. Okay, if the gradient then is -1, what do we then do? We are then able to know that the gradient of the radius, or the gradient of a radius, plus the gradient of a tangent to a circle, if you multiply them, it's always, the result is always -1. Why is that the case? Well, it is always the case because we know very well that your tangent is always perpendicular to your radius. It's always perpendicular to your radius at the point of contact. At the point of contact. So now we know already the gradient of the radius. Why? Because this is the equation, and in this equation, we're able to see, okay, it is coming from the slope-intercept form of the equation of a line, y equals mx plus c. Now look at this. The gradient is -1 there. Okay. Now, what do we do? What do we do? We continue to then say, we want to find the gradient of the tangent. So we substitute here. That of the radius, the gradient of the radius, you put a -1. Equals -1. The gradient of the tangent, divide by -1, you multiply both sides by -1, getting a 1. Like this. Getting a 1 like that. So now we know the gradient, but now this tangent passes through the point, because they said the equation of a tangent to the circle passing through P, Q, and R, the circle passes through P, Q, and R at point P. The tangent is at the point P. It's a line through the point P, and therefore this tangent is through. Right, so this tangent is through. Right, so this tangent is through. It is through 1 and 1. Right, so this tangent is through P with coordinates 1 and 1. Right, so we're going to use y minus, which is the slope point form. Right, which y minus y1, which is m into x minus x1. Okay, we continue. x1, y1. y1, the m is 1, x minus x1. All right. So you have x minus 1. And then now you have x. You have exactly the equation y equals x. Because even here, when you get here now, we have this. So you can have -1. And then this one, you bring it across. So it becomes +1. In which case, therefore, this implies that y is x. Y equals x. Okay, we found therefore the equation of the line that the examiner wants, in particular, the equation of the tangent. What is the equation of the tangent? The equation of the tangent is clearly y equals x, and we have solved that question, but we solved that question with a great deal of detail. So yeah, take a look at that and make sure you understand what is happening, and make sure that all is well. So look at these, think about it, and make the most of your time. Make the most of your time. Where's the question? Where's the contribution to make? Maybe you're seeing a mistake somewhere. Maybe you're seeing something is missing. We need to add something, or we need to remove something. Okay, so you can Oh, you're always welcome to let us know. Okay, another question the examiner asks is, calculate the size of the angle theta. Calculate the size of the angle theta. Right, so we continue. So we continue. We continue. We continue. So in the end, then what we then have is as follows. Right. Okay. Right. So if you want to calculate therefore the size of the angle theta, this one, the size of the angle theta, that one. So now to find the size of the angle theta, we proceed as follows. We proceed as follows. Right. The couple of things that are very important. We look at that next. We want to find the size of this angle. So now, what is the size of that angle? You see, there are a couple of ways to obviously find the size of that angle there. There are a couple of ways to find the size of that angle, and we shall continue to do so. We shall continue to do so. Okay, so we continue. Right, we continue. We continue. So determine the equation of a tangent to the circle. Right, rather to find the size of the angle theta. This one here. We're going to use the formula. What is the formula for finding the size of an angle in analytical geometry? It is the gradient formula. We know that the gradient is the tangent of theta. Right. So we continue. Right. We continue. We continue. So in this formula, we use this formula to find the size of the angle theta. So we shall find first, we shall note that this up here is the point P with coordinates 1 and 1. Right. So we continue. Right, so we can find a couple of angles, like, for example, you can find P and T, you can find this angle of inclination. Let's write that one clearly. Right, so P is those coordinates, and therefore that would be so we continue. So now this is the point P up there. So now you can find the angle P and T. So we can find the gradients, or rather the tangent. Okay, let us find the tangent. So let's find the tangent of the angle P and T. This one, P and T. Okay, the formula we use to find angles in analytical geometry is the tangent formula. So we find P and T. Right, by P and T, we want to find this angle. What is this? P and T is the gradient of PR. Okay, so the tangent of P and T would, because this is one line, so it will be the same as the gradient of the line P to R. And the gradient is -1. So what is the angle of inclination of this line? Right, this allows us to find what we call the angle of inclination. What is the angle of inclination of a line? Right, the angle of inclination of a line is the angle made by the line with the positive x-axis. So we always make our angles here like 0 degrees and so on. Okay, we remember that from trigonometry. Okay, so we continue with the business of the day. If P and T is equal to -1, then we can find we find first the reference angle, which is arctan of -1. Okay, but the reference angle is always found with a plus. So even if the right hand side is negative, but we want to find the smallest possible angle in the first quadrant, so we use the plus there, and therefore arctan 1. Right. So arctan 1 is 45 degrees. Okay, this is not this angle here, but it is a reference angle that's associated with this number 1. Now, if this is a reference angle, what do we do? We then take this reference angle and we find something. We find the actual angle P and T. Okay, if ever, in which quadrant is the tangent negative? It is negative in the second quadrant. So this angle is an angle we can see it's bigger than 90 degrees, so it's just 180 degrees minus 45, which is 135 degrees. Okay, meaning this angle here is 135 degrees. Okay. So what do we do? So we continue. We continue. We continue. So that then in the end, we have the following. If this angle is 135 degrees, okay, this also, I mean, we can do a lot of things there. We can find a lot of the angles, but let us find angles that are very useful. Right, we found that angle. And so what do we do with that angle? We continue to analyze these very carefully. You can find another, the tangent also. Let's find this one. We can find the tangent of PMT. The tangent of PMT. Right, so the tangent of the angle PMT is the gradient of the line PQ. P is up here, Q is this one. So it's the gradient of the line PQ. And the gradient of the line PQ, we found it to be 3. Remember, gradient of PQ found it to be 3, or QP. We called it QP, but yeah, we found it to be 3. And we continue then, and we solve more problems. We solve more problems. Right, we solve certainly more problems there. Right, so in solving more problems, we obtain the following. We obtain the following. We obtain the following. So we solve. We have the following. Right. We have the following. Right, so at this point, what we then do, we then continue to analyze this, but I want to find the gradient that's associated with that. Okay, can we therefore, let me speak to this student here. Right, yes, how are you? Very well, yes. You're doing well?
Yeah.
Why didn't you join the class? Because there's a class now on Zoom app, and I sent the link on the WhatsApp group. Why did you not join the class?
Okay, I'm about to join.
Yes, because now the class is ongoing until 6, and we started at 4 already. And I expected you to join the class.
So,
Yeah, so now refer to the group, WhatsApp group, and tap on the link because there's a link there.
okay.
And then now you need to tap on that link on the WhatsApp group, and you'll be able to join the class. Okay, because I expected you to join the class because we spoke about this earlier on. Yeah, so please join the class because the class is ongoing until 6. So we still have about 1 hour to go. Okay. All right, thanks.
Sharp.
All right, thanks. Okay, yeah, so we continue now. There's this student that is has just been this student was missing the class. Okay, because I don't know why. Okay, so we have that. Then now we found that the tangent of PMT, of the angle PMT, so the tangent of the angle P is this one up here, MT. So this angle here, the tangent of this angle here is equal to the gradient of PQ, and it is 3. PMT is 71 degrees. Okay. PMT. Now to find the angle PMT, because it's positive, we can just, if it's positive, there's no need to find a reference angle. So you find arctan 3 using a calculator. You have 71,57 degrees. 71,57 degrees. So we continue. We continue. So we continue. Continuing, we have the following. Right, and this gives us exactly this angle of 71,57 degrees, meaning this guy, this angle. PMT is equal to 71,57 degrees. Okay. So now we have exactly that. The question then becomes, what is the angle theta? So this one, let me do it in red. This one already know is exactly 90 degrees. And then if this is exactly 90 degrees, this angle P now we're going to get, because this one is equal to this plus this, exterior angle of a triangle from grade 10. Exterior angle of a triangle, this angle is equal to this plus that. In other words, now we're able to see that the angle P, the angle P is equal to 135 degrees minus 71,57 degrees, which is 63. 63,43. Okay. Like this. So now, if this angle P is 63,43 degrees, so we have a triangle that is doing some aerobics. Okay, look at these. There is one here, 90 degrees. Okay. 63, 26,43 degrees is up. And then this one here is theta. Is theta. So we just need to find this one. What is the angle theta? Now, we already know this one, P. You already know this one is 90 degrees. You just need to find the third one. So this one is back to the sum of angles in a triangle. So we're able to see that the angle theta. Okay, so here you must state the reason. You must state the reason why we just said 135 minus 71. Here, 135 minus 71,57. The reason for this is exterior angle of triangle. Exterior angle of triangle. Exterior angle of triangle. Exterior angle of triangle. So we continue. We continue. So yeah, I want to find the size of the angle theta. So yeah, the angle theta is actually exactly this one. So we already know this angle. You already know this angle. So what do you do now if you know two angles? Yay! So the angle theta is this one. So to find the third angle, you just say 180 degrees because you're dealing with a triangle. You're dealing with the sum of all the angles. So it's 180 degrees minus 90 degrees minus 63,43 degrees. Subtract all of them. 26. Can even write it here above. It's okay. Can write it here. We can write it a little bit above here. So yeah, we're able to say the angle theta. The angle theta that is wanted is 180 degrees, 180 degrees minus 90 degrees minus 63,43 degrees. So then the result is therefore 26,57 degrees. 26,57 degrees. And therefore, as a result, we are interested in giving the reason here. And this is the sum of angles in a triangle. This is exactly the sum of angles in triangle. This is the sum of angles in triangle. Sum of angles in triangle. So what is the angle theta? The angle theta is actually 26,57 degrees. So obviously, I mean, this is what the examiner asked us to do here, and we're able to state that up front, that the angle theta, Miss Examiner, is actually 26,57 degrees. Right, where's the question? Please, if you have a question, let us know. If you have no question, you have to still let us know, because we're good and we're cruising and we're getting the most here of our stuff. And yeah, let us look at the next question. Next question. Right, so in the next case, we're going to look at this circle. And we want to deal with this circle, but also want to be in a position to solve this question in detail. In the diagram below, the equation of the circle with center O at the origin is x squared plus y squared equals 20. So this is the equation of the circle. The tangent PRS to the circle at R, this a tangent PRS to the circle at R has equation y equals 1/2 x plus k. So we have that PRS cuts the y-axis at T, okay, and the x-axis at S. Yeah, the x-axis is at S. Determine giving reasons the equation of OR in the form y equals mx plus c. Y equals mx plus c. So we have the following. We have the following. Right, so now let's look at 4.1. Let's look at 4.1. Determine giving reasons the equation of OR in this form. OR. What is the equation of OR? Equation of OR. Right, so obviously, I mean, you have O and R. O is the origin. And now to find the equation of OR, there are a couple of things that remain very, very important. Mr. Examiner. Right, very smart question. But now you need to note that first we have the tangent. This tangent. This tangent touches the second. So you have the gradient of the tangent. What is the gradient of the tangent? Right, so the gradient of the tangent, just write tangent here. So the gradient of the tangent is 1/2. What is this tangent doing? What is it doing? It is touching the circle at most at one point. And why are we saying the gradient is this? Because the equation is this. Because the equation is y equals 1/2 x plus k. Y equals mx plus c. Okay. Okay, so we continue. We continue. Right, so now to continue, we do the following. We need to know, therefore, that the gradient of a tangent multiplied by the gradient of a radius at the point of contact, this is -1. Why is it -1? Because we know that a tangent is always perpendicular to a radius at the point of contact. This tangent is 1/2. So that we have the gradient of the radius. And it's -1. Cross multiply the gradient of the radius is -2. This is the radius. The tangent is gradient 1/2, and therefore the gradient of the radius is -2. So that then in the end, we want to determine giving reasons the equation of OR. But now the equation of OR passes through. Passes through the origin. Y minus y1. M into x minus x1. Okay, the origin. So y minus 0 minus 2 into x minus 0, which means y is minus 2x. So the equation, determine the equation of OR in that form. So the equation of OR in that form is actually that one given over there. It is that one given over there. It is actually as given just minus 2x. Check that. So obviously, I mean, we're effectively then saying the equation in the form here is minus 2x. Okay. All right. Yeah. 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 Okay, so we continue. We continue. Right, so now you want to find the coordinates of R. Open to. The coordinates of R. Right, who can find the coordinates of R? Can I give you like 1 minute? Find the coordinates of R quickly. Find the coordinates of R quickly. If we're doing 4.2, if you already know that the answer here is minus 2x, find the coordinates of R quickly. What are the coordinates of R? What are the coordinates of R? Who can find the coordinates of R? Who can find the coordinates of R? Who can find the coordinates of R? Right, so R is a point of intersection of this OR has this equation, so you have y equals minus 2x, but this one is a circle, and it has an equation that intersects OR at the point of contact here where this circle meets the radius. So in which case, therefore, we're able to say is a point of intersection. So you have two equations. You need to just solve these two equations simultaneously. It's a point of intersection. So you have x squared plus y squared is 20. But you also have y equals minus 2x. Okay, you have that. So what you do is you put 2 into 1. So put 2 into 1. And if you put 2 into 1, wherever there's y, you can put minus 2x. So you have x squared plus. The y is minus 2x. The y is minus 2x, which equals 20. X squared plus. If you square minus 2, you get 4x squared equals 20. You have 5x squared equals 20. Okay. Because x squared plus 5x squared is 5x squared. You divide both left and right by 5, getting x squared equals, okay, let's write a little bit more steps dealing with school here. So let's just show some trivial steps. So you have 5x squared divided by 5 equals 20 divided by 5. In which case, therefore, you have x squared equals 4. If x squared equals 4, you take the square root of x squared, it must equal plus or minus the square root of 4. X equals plus or minus 2. Okay. What is R? X at this point is on the positive side. So x is plus or minus 2, but at this point you have that. Therefore, x equals 2 because x is positive here. So this R is on the positive side of the x, but you get a y as well. What is y? So obviously we use one of the equations. So y equals minus 2x. X is 2. Minus 2 times that is minus 4, which is minus 4. Okay, yeah. So the coordinates of R are 2 and minus 4. So we continue to solve more problems. We continue to solve even more problems. So the coordinates of R are those. The coordinates of R are those. The coordinates of R are those ones. And we continue to solve more questions. Continue to solve more and more problems. We have obviously at this point, the point R with the coordinates 2 and minus 4. And if this is the case, we have the following then. We have the following. Right, so welcome the student who just joined now. And normally I don't show a lot of pictures on the screen. I just hide the pictures because the interest is in just learning than anything else for us. So we can sometimes show the pictures and see this one, see that one. We're going to have those sessions like that. Right, we're going to have those sessions like that. So yeah, but we then continue. So the coordinates of R, therefore, the examiner wants them, what are they? For this question, the coordinates of R are X is exactly 2 and Y is -4. X is 2 and Y is -4, and those are the coordinates. Those are the coordinates. Those are the coordinates. So we continue. Those,
Okay.
yes, welcome. Right.
Yeah.
Yes, we're doing analytical geometry. Right, we're doing analytical geometry, and at this point, we attempted to find the coordinates of R, and R is a point here, a point of tangency. We can see on the diagram, right, that there is a tangent. The examiner said the tangent PRS to the circle at R has the equation y equals 1/2 x plus k, and we can see that. Okay, we have solved that question, and we move on to the next one. Right, the next question is question 4.3. In 4.3, we want to determine the area of triangle OTS. Right, here is O, here is T, and here is S. OTS. Want to find the size of this triangle here. Want to find the size of this triangle here. What is the size of this triangle? Okay, that's a very wonderful triangle that looks like a boot, like a soccer boot. Anyhow, okay, we can find the area of that triangle, but that triangle is a very, very awesome one. There are a couple of things we need to know, obviously, but what do we need to know? We need to be in a position to know the length of the sides. Right, to find the area of this triangle, we need to find the length of the sides. And so now, what do we know? We need to know a couple of things, but let's first do this. Right, let us first take note of the fact that we're gonna say that through, right, exactly through, right, right, through the point R, R has the coordinates. We've seen the coordinates of R, we found them to be 2 and -4. 2 and -4. Those are the coordinates of R, 2 and -4. So the coordinates of R are exactly 2 together with -4. Through the point R, we have the equation, which is 1/2 x plus k, which means that -4, 2 plus k, -4, 1 plus k, -5. Okay, so we have k equals -5. And then now this equation of the line is actually, then we found a k, because this equation of the line was given as y equals 1/2 x plus k. But we've already got the numerical value of k, and we got k to be exactly that one. So, right, we're able to then say that the equation of the line was given as 1/2 x plus k by the examiner, but it is exactly 1/2 x minus 5. If this is the case, we want right now with the moment to continue, to actually proceed to find the area. Right, to find the area now, we must find the intercept with the axis so that we can easily be able to find the lengths of the sides. So we proceed as follows to find the length of the sides. So now a couple of things remain very, very important here. So for instance, we want to know the x-intercept. So now we find, so obviously with this, and we found k, and this is that. Okay. X minus 5. Look. Okay. So, now we can just say we're interested in the x-intercept of this line here. So to find the x-intercept, how do we find the x-intercept? To find the x-intercept, we let y be equal to 0. Y equals 1/2 x. Okay, let's just continue. 1/2 x. Y equals 1/2 x minus 5. But obviously, I mean, we're saying effectively y is 0 here. So if y is 0, we're able to see, therefore, that y is 0, so that 0 is 1/2 x minus 5. This implies that you bring the minus 5 to the other side, so that we have 5 is equal to 1/2 x. You cross multiply, 2 times 5 gives us 10 equals x. I mean, that is telling us that we know the coordinates of s. X is 10 and y is 0 at this point. At this point. And so now we therefore continue to solve more problems at this point. Right, let me just speak to this student here. Yes, hello, Precious. I'm in class at the moment, until 6. Okay, thanks then. Okay, thanks, goodbye. Right, so we continue right now to analyze these questions, but to look at what we can do better. What we can do better. Okay, we know that this is 10 for x. It is exactly 10. So, I mean, it is telling us in a nutshell that our OS, right, it's telling us that OS, this is O and that is S here. OS is 10 units. It is telling us that OS is 10 units. So then we want to then find the area of triangle OTS. So area of triangle OTS is actually the same as half base by height. The area of a triangle is half base by height, which is half the base. What is the base? The base, we can take the base to be this one here, which is exactly 10. Multiplied by the height. What is the height? Okay, you take the base as this one, the height is going to be up to OT. And now, what are the coordinates of T? What are the coordinates of T? Okay, so obviously, I mean, we know very well, this is the straight line here. And the y-intercept, because is y equals 1/2 x minus 5. So the y-intercept is minus 5. Right. So that now OT is 5 units. OT is 5 units. Okay. With half of 10. What is the half of 10? It is 5 by 5. What is 5 times 5? 25. So the area of the OTS, triangle OTS, is 25 square units. 25 square units. 25 square units. 25 square units. Okay. 25 square units. Where's the question? Who doesn't understand what is happening? Who is lost somewhere? Who is saying, hey, why did you do this? Where is that? Because what was the question? The examiner said determine the area of the triangle OTS, given that the point R has the coordinates 2 and -4. We already got that R has the coordinates 2 and -4 before. We did that in the previous question, because in 4.2 we found the coordinates of R. So yeah, we're good. We're good. We're good. So we continue right now to solve more problems. Continue to solve the next question, 4.4. Right, in 4.4, want to calculate the length of VT. The length of VT calculate the length of VT. Okay. Calculate the length of VT. So there's a V here, there's T here, and the examiner is saying find the length. The distance from here to there. What is that distance? What is that distance? Let us find the length of VT. What is the length of VT? A couple of things we know. I mean, we already know the coordinate of t because we know the equation of this line from the previous question. And the equation of this line from the previous question is y equals 1/2 x minus 5. Yeah. So yeah, we continue. We continue. Yes. Okay, the length of VT. What do we do to find the length of VT? We find it as follows. To find the length of VT, we just need the coordinates of t because we already know, well, the coordinates of t already know because this t is the y-intercept. So the y-intercept is -5. So if this is -5 here, then it means the coordinates of t are x is 0 and y is -5. That we can see. This will give us actually the coordinates of the point t. We therefore just need the coordinates of the point v. But how do you find the coordinates of the point V? It is something that is very, very straightforward because we already know something. What do we know? We already know the coordinates at this point of the point, for instance, the point R, the point R. What are the coordinates of the point R? Right, we already know the coordinates of the point R. R has the coordinates, this one. 2 together with -4, and therefore we can find the coordinates. So in other words, now if you give a line like this, and this one is the origin, and this is a diameter because it passes through the center of the circle, and also the point R has the coordinates 2 and -4. It's a midpoint concept. And V has its x, v, y, v coordinates. And now we are excited. The origin has the coordinates we know because they're 0 and 0, and it's all good and well. And we're excited to then say we can find then the coordinates of the point V, if you know the midpoint formula. So we're going to deal with something called the midpoint. So now the midpoint formula is as follows. What is the midpoint formula? X1, X2 out of 2. Y1, Y2 out of 2. Okay. X1, Y1. And then here we have X2, Y2 as the coordinates of V. x2, y2 is the coordinates of V. So we continue. Right. So we have the following. We have the following. Right, so obviously, I mean, we have x1, which is 2. x1 is 2. x2 is x at the point V out of 2. y1 is a minus 4. y2 is yv out of 2. Okay. Right, so now the midpoint is the origin, which is 0 and 0. So now here we're finding the midpoint. So you take x1, you add to x2, you divide by 2. You take y1, you add to y2, divide by 2. This is the midpoint. But it is equal to the midpoint, which is the origin, 0 and 0. Okay, for this here, this is the midpoint. Okay, because this OR is a radius and that is a radius. So then in the end, we're able to then say you have 2 plus xv out of 2 equals 0. And you have minus 4 plus yv out of 2 equals 0. You cross multiply, 2 plus xv equals 0. And minus 4 plus yv equals 0. And xv is that. And this is 4. Okay. Okay. Now we have the coordinates of V. Because we have x at V and y at V, and we're excited. We are thrilled to write down the following. So yeah, we're excited to then say the point V has the coordinates. Just write a little bit further away from the point O, because then it's gonna be a total mixture, and somebody's gonna be like, hey, this guy here. So yeah, the V has the coordinates -2 and 4. Okay, this is awesome stuff. I mean, you can easily be able to find the coordinates of V either way without even a calculation, and this is a very strong observation, because if the coordinates of R are 2 and -4, and these are on the same line that passes through the origin, you can view this one as a rotation. You can rotate OR about the origin. And if you rotate OR about the origin, it will then actually become the point V, whose coordinates are -2 and 4. But now just look at what they are doing. Yeah, hello, Trondre. Yeah, fine, thanks. I'm in class until 6. Please come again. Yeah, by 6. 15 minutes. Thank you. Yeah. Okay, thanks, Trondre. Okay, thanks. Okay, so you continue then. Okay, I want us to do something here. Okay, but remember that we're just finding the coordinates of what? We're just finding the coordinates of V. Why are we finding the coordinates of V? But why? Because you want to find the length, and to find the length of VT, we must know the point V in terms of its coordinates, but we must also know the coordinates of T. VT, you must know the coordinates of V and those of T. And that is how we can find the length of VT. So at this point, we continue to do the following. Okay, yeah. But I was saying, it's like we rotated these. If you rotate this one now, the points, it's 2 -2, -4, 4. So it's like this have just been multiplied by negative. And this is what happens. It's called the rotation through 180 degrees. Just you hear me. It's a rotation through 180 degrees. That is what it does. So if you take a point and rotate through 180 degrees, you just multiply the coordinates by what? By by -1. So that 2 becomes -2 and a -4 becomes a +4. Okay. I want us to find the area, okay, rather the length of VT. Okay, we already know the coordinates of V and those of T, so yeah. Therefore, we then say, what do we then have? Okay, we have V with coordinates -2, 4. We have T with coordinates 0, -5. X1, Y1, X2, Y2, which means VT X2 minus X1 squared. Y2 minus Y1 squared. This is called the distance formula. And therefore now we continue to find the distance. So we continue here below. And if we continue here below, we are able to find VT, which equals. What is X2? X2 is 0. What is X1? It's -2 squared. What is Y2? It's a -5. Y1 is a 4. Okay, you square this, it becomes the 4 plus 81. Okay, yeah, which is exactly 85, square root of 85. So the length of VT is actually there for the distance formula we use, we substitute it, and it is the square root of 85 units. It is actually the square root of 85 units, like so. So we continue. We continue. Right, we continue. So we look at the next question. Okay. Okay. There are too many questions, but I want us to focus on the things that are for this term, not on the things that do not matter. Okay, in the diagram below, tangent KT. So you have tangent, this is K, and that is T. Right, to the circle at K is parallel to the chord NM. Parallel to the chord NM, and this is the chord. NT cuts the circle at L. NT, N. T cuts the circle at the point L. Right, this triangle KML is drawn. Triangle K, M, L. This triangle is drawn. The angle M2 is 40 degrees. The angle MKT is 84. So we have 40 degrees, which is the angle M2, and also the angle MKT. Right, MKT, that angle is 84 degrees. Determine given regions the size of the angle K2. We want the angle K2. We want this angle here. We want this angle here. When this one is a tangent to the circle, right? So we're good. We're good. So who can find the size of the angle K2? This one. What is the size of the angle K2? Right. What is the size of the angle? Who can find it? Please let me know when you've got it. Let me give you a chance to practice with us the geometry. Right. Anyone home? What is the size of the angle K2? And why? Right. Tando. What is the size of the angle K2? We're doing 8.1. We want to find the size of the angle K2. What is the size of the angle K2? Please answer the question. Okay, Tenulo. What is the size of the angle K2?
40, sir.
It is 40. Why is it 40, Tenulo? What is the reason?
What's this theorem?
Mm-hmm.
Exterior angle. Oh, sir, I forgot this.
Okay, that's fine. But yeah, I'm happy that you're trying. Yeah, I agree with you.
Angle.
Yeah, I agree with you. I agree with you because there's a tangent. So there's this theorem that is like this. There's this theorem that is like that. And then you draw something like
Exterior
this.
angle of a triangle is equals to the opposite or whatnot, subtending angle.
Yeah, I get you.
Like
I get you. So there's an angle between a tangent because they said here tangent KT. So KT is a tangent. There's an angle between a tangent to a second and a chord. It is equal to the angle subtended by the chord, and this chord subtends this angle. So this angle here, it is the angle equals to this angle here, and that is called because there's a tangent and a chord. It is called the tan chord. It's called the tan chord theorem. It is called the tan chord theorem. Okay, there's a tangent because they said tangent KT here. So there's a tangent KT like this. And then now you have this. And this angle that sits here is equal to the angle that sits there. In other words, we're able to see, therefore, that we have the following. We have the following. So we're able to see, therefore, that we have that the angle K2 is actually equal to M2. The angle K2 is M2. Angle K2 is M2 and it's equal to 40 degrees, which is the tan chord theorem. Tan chord theorem. So the angle K2 equals M2, which equals 40 degrees. The angle K2 equals M2 equals 40 degrees. Angle K2 equals M2 equals 40 degrees. Then the next thing we want to do angle N1. The angle N1. The angle N1. Right, so now if this one is 40 degrees, who can find the angle N1? This one. This one. What is angle N1? N1 home, let's give you a chance to practice with us. What is the size of the angle N1? Who can get the angle N1? Right, who knows what the angle N1 is here? Who knows what the angle N1 is here? Right, anyone home? There's no one home. Perhaps there's nobody. Yeah, but somebody should be here to say, hey, I know what it is. I know what it is. Angle N1, who can find it? I'm giving you a chance to practice, but also I'm giving you a chance to shine. I'm giving you a chance to shine.
N1 is 84, sir.
You think that N1 is equal to 84? Okay, okay. A very good attempt from Tando. Thanks for that attempt, Tando. Okay, now the couple of things that are very important. But first things first, you can see that N1 is equal to this angle here. So we can see that first things first here, the angle N1 is equal to the angle K1. And then, now this is true because these are, they form a butterfly like this. They form a bow tie. They form a bow tie because now if you have this bow tie like that, okay, let me draw the bow tie thing here. Right, so you have this here and this. this angle here equals this angle there, and this angle here equals this angle there. Okay, so y'all take note of that. Okay, in principle, then we have the angle N1 equals the angle K1, and these are angles in the same segment. Angles in the same segment. Okay. Angles in the same side. Okay, what do we do next? But the challenge is one, is that we don't know this angle here. We know the whole thing, but we also know this one is 40. But we can say that the angle K1, the angle K1 is 84 degrees. 84 degrees minus 40 degrees. So the angle K1 is 84 degrees minus 40 degrees. And that is, what is 84 minus 40 is 44 degrees. This gives us that this angle is 44 degrees. So that 44 degrees plus 40 degrees is 84 degrees. 84 degrees. Okay, right. Now we are in business because we found K1. And we can then say, hence, the angle N1. The angle N1 is equal to the angle K1, which equals 44 degrees. Like so. And obviously, we've already got the angle K2, which is 40 degrees. The angle N1, which is 44 degrees. And then we continue. We continue. Okay, we continue. Okay, what next now? We want to find angle T. Who can get the size of the angle T? Anyone home? So in other words, we've got some of the angles. I mean, here we've got 40. Here we got 44 degrees. This
It's
one,
44.
please come again.
It's 44.
You think T is 44?
Yes.
Why? Why? I don't know. I mean, that was quick, but why?
Alt angles. Because the N and
Well
K are
done, well
parallel.
done, well done, well done. Yeah, now that is smart, but that was quick. I was shocked that Tsenelo just gave me the answer and I was just writing 44 and he was saying 44. I agree with you, Tsenelo, because now this one here, this is what the angles are doing. This one is going there and this one is doing this. And now if they're doing this, they're doing a Z thing like that. So you have therefore that the angle T is equal to the angle N1. The angle T equals this angle N1. And therefore it is equal to 4 degrees. And these are alt angles. They are alternating angles. Why are they alternate angles? They're alternate angles. So you write alternate angles because they're two parallel lines. What are the parallel lines? The parallel lines are exactly KT. KT parallel to NM. NM. 44 degrees. 44 degrees. Hey, just 44 all the time. Just look at these questions and look at the examiners. The K2 is actually 40 degrees. Now, the next thing, let us find the angle L2. Who can find the size of the angle L2? Okay, so yeah, we need L2 now. This one, you know, is 44. This one is 40. So we was able to find this one 44. This one is 44 degrees. Yeah. Then now, what is L2 now? This one. L is this one. And then L2 is this. But what is the size of L2? What is the size of L2? What is the size of L2?
96.
That sounds very smart, but why do you think it is that way there, Tsenelo? Why?
Sum of angles on a straight line.
Sum of angles in a straight line. Yeah, that sounds awesome. Okay. Because this one reminds us of grade. It reminds us of grade 10. Grade 10, there's a triangle that is like this from grade 10. So in grade 10, if they do this, and then they do this, and then they call this one 1, 2, and then they mark some angles like that, and then now they put this one 1, and then this is C, A, B. Then they say angle C1 is equals to angle A plus angle B, and this is the exterior angle of triangle equals the sum of the interior opposite. So it is the same one. So we can say L2 is this one plus this one. We've already got that in there. So we say L2 is K2. So L2 is K2 plus T. K2 is 40. T is 44. And this is 84. Yeah. So L2 is 84. Okay. Yeah. T is 44. N1 is 44. K2 is 40. And then we need L1. Now we need L1. What is the size of this angle? L1. We need L1 right now. Who can find the size of the angle L1? Who knows? All right, okay. But yeah, the reason for this. As I said, so because we're saying L2 is 40 plus this, 40 plus 44, and the reason is exterior angle of triangle. Okay, we already know if you write like this, the examiner already knows exterior angle of triangle equals the sum of the interior opposite angles. The sum of the interior opposite angles. Okay.
Sir,
Yes, please. What is
can I
L1?
ask
Yes,
can
please.
I ask something?
Yes, please.
Does angle subtended by a chord still work if there is no diameter? Because isn't it a chord is a line that
Yes,
touches
yes, yes,
from
yes, they
circumference to
work, they
circumference?
work, they work.
So that
Oh,
so that means this is angular chord because you're gonna minus L2 and then from 90 you're gonna get L1.
okay, yeah. So now if we are, let's see what you say there. Yeah, So what do we do now here?
Because isn't it angle subtended by a chord is equals to 90?
Okay. I get you.
And we have L2
All right.
and that angle is equals to 90. That
All
the whole
right.
angle of the whole L1 and L2 are equal to 90 both of them. So if we minus L2 to get from 90, we must get L1.
I hear you. Okay, yeah, but for a chord subtends angles, but for the angle subtended by chord to be 90 degrees, that must be a diameter passing through the center. Okay, so okay, I hear you. So you're on point. Right, so but now we can deal with the rest of this. Okay, we are on point. So already know this one is 40. This one is 44. This one is 84. L2 is 84. So it's a triangle. In this triangle, there's 44, there's 40, there's. So you can just add everything in this triangle. It's only this one that is left. Because you already know L2 is 84. So, yeah. So to find L1, this one you already know is 84. And this one is 44. This one is 40. So it's only this one we want, that we want. So yeah, but obviously you're on point. There are many ways to find these questions, obviously. Geometry, there are many ways, many theorems you can use. But now we can just choose to work in triangle KLM and then say we're going to take 44 degrees, this one, and then we're going to add 84 degrees. Then we're going to add 40 degrees. Then we're going to add L1, and it's 180 degrees. Why? Angles in triangle. Angles in triangle. Okay, yeah, we can just say, it's also acceptable to say, in short, we say angles sum in triangle. Angles sum in triangle. And with this, then we're able to do algebra. Angle L1 is 180 minus 44 minus 84 minus 40. Okay, it's 12. So the angle L1 is 12. Yeah. Angle L1 is what? It's exactly 12 degrees. Right, it was awesome having you guys, and thanks a lot for joining us. Yeah, I'm going to be right back at 8 p.m. For those who have a lot of energy, I'm going to evaluate what we can do at 8 p.m. Okay.